Okay, if we want to use pi over 6, then this has to be cosine, and this must be sine. Perfect. Okay, so let's continue. So I'm going to rewrite it. I'm going to rewrite it correctly. Sine pi over 6 cosine theta plus cosine pi over sine theta cosine pi over 6 equals 1/2. Now, what does this mean? And what do I replace it by, in other words? Which identity is this? Sine A cosine B plus sine B cosine A. So how do I write this? Instead of a sum, how do I condense it? Which identity will apply here? Anyone, please? Please.
Sine A plus B.
Exactly. So I have to write sine pi over 6 plus theta. Sine pi over 6 plus theta equals 1/2. Indeed. Sine pi over 6 cosine theta plus sine theta cosine pi over 6. Excellent. Perfect. So now let's look at the unit circle. Sine is 1/2 or positive in these two quadrants. Can anyone give us the two angles that sine pi over 6 plus theta could be? So pi over 6 plus theta could be which angle in the first quadrant and which angle in the second quadrant? So one here and the same height, one here. Which angles are those? Whose sine is pi over 2? I'm sorry, whose sine is 1/2 in the first quadrant and whose sine is 1/2 in the second quadrant? Which angle?
Pi over 6 and 7 pi over 6.
Excellent. Pi over 6 and pi minus pi over 6. Pi
over 6.
Yes, 5 pi over 6. Indeed. Yes, you can add the 2 pi k here. It's not going to make any difference. So when k is 0, k equals 0, theta is 0. These two go away. When for the other one, when k is 0, theta is 5 pi over 6 minus pi over 6, 4 pi over 6, 2 pi over 3. Let's also try k equals 1, see what happens. So for k equals 1, the theta will be 2 pi. But the problem was asking us to have the answers only between 0 and 2 pi and not 2 pi. So there is no need for this. And for the other one, it's even more above, right? So theta will be 2 pi over 3 plus 2 pi, which is way above 2 pi. So these are the only two solutions. Okay, so 6.5 is complete, done. Please finish it up by Wednesday, at least 70%, and please ask questions in class. Okay, we're moving on to the last set. I'm trying to find it. Here it is. So the last set deals with double angle and half angle formulas. So let's discuss those, and then we'll look at problems. Okay. So let's start with double angle formulas or identities. 6.6, double angle identities. Double angle identities. Okay, so what does this mean? Well, very simple. We had, for example, we had cosine alpha plus beta, which was cosine alpha, cosine beta minus sine alpha, sine beta, as an example, right? Same thing, sine alpha plus beta. Same thing with tangent alpha plus beta. Now what happens is both are the same. Alpha plus alpha, or beta plus beta. So this formula, let me start with sine alpha plus beta. So the formula is sine alpha cosine beta plus sine beta cosine alpha. But if they are the same, I have sine alpha cosine alpha plus sine beta, plus sine alpha cosine alpha. So then sine twice alpha is twice sine alpha cosine alpha. So that's the first double angle identity. Where it's coming from? From replacing alpha by beta or beta by alpha. In other words, alpha plus alpha. So sine twice alpha, you get sine alpha cosine alpha plus sine alpha cosine alpha, which makes it 2 sine alpha cosine alpha. So this is the easiest. Now, what I would like you to understand is that this is a dynamic situation. What do I mean by that? It's not static. So if I get this, I have to be able to come up with sine twice alpha. If I'm getting this, I should be able to come up with this. But what if I have, let's say, sine 7 alpha? How would I write this? Very simple. How do I get this? Dividing 2 alpha by 2 to get alpha. So that's fine. 2 sine 7 alpha over 2 cosine 7 alpha over 2. What about sine 4 alpha? No problem. 2 sine 2 alpha cosine 2 alpha. What about sine alpha over 2? No problem. 2 sine alpha over 4 cosine alpha over 4, and I can go on forever. So these identities have to be understood that this is not carved in stone. This 2 alpha is not carved in stone. As long as you understand the relationship, whatever I have here, I have to have this divided by 2, and vice versa. Whatever I have here, I have to have this doubled here. So all these are based on the same identity. So this identity says sine of twice any angle must equal 2 sine of the angle cosine of the angle. Sine of the angle, sine of twice the angle. Cosine of the angle, sine of twice the angle. And again, we can go on forever. Now, let's look at cosine, because this one has 3 identities. Just this one. Very simple, though. And here's how we start. We start with the same. Stop me if you have questions, please. So we start with the same thing, cosine alpha plus alpha, which we know was cosine alpha times cosine alpha minus sine alpha times sine alpha from the formula from alpha plus beta. If they are the same, this is nothing else but cosine twice alpha. But cosine times cosine, so then cosine twice alpha is cosine times cosine is cosine squared alpha minus sine times sine is sine squared alpha. So this is the first form. What will be the other two? I would say very simple, because we know that this one is 1 minus sine squared alpha. And then later on, this one will be changed into 1 minus cosine squared alpha. We know this from a long time ago. That's the simplest identity. Sine squared plus cosine squared equals 1. So therefore, when I replace this by this, I get 1 minus twice. So the second form is cosine twice alpha equals 1 minus twice sine squared alpha. And that's the second form. And when I replace this by 1 minus cosine squared, I have minus 1 plus. So the other form, the last form, cosine twice alpha, is 2 cosine squared alpha minus 1. So this is coming from cosine alpha plus alpha. So it's cosine squared minus sine squared. It's not cosine squared plus sine squared, which is 1. It's cosine squared minus sine squared. If I replace this piece by this, I get the second identity. If I replace this piece by this, I get the third identity. So this is 1, this is 2, and this is 3 of the same thing. Finally, the tangent, and then we'll look at problems. So tangent twice alpha. And of course, cosine 7 alpha is 1 minus twice sine squared 7 alpha over 2. Like we just did with sine, we can always do the same things. Any angle here has to be divided by 2. Any angle here has to be divided by 2. Any angle here has to be divided by 2. So the same rule applies to. So what is this? Nothing. Tangent alpha plus alpha. Well, we know that this will be tangent alpha plus tangent alpha, which is twice tangent alpha, over 1 minus tangent alpha times tangent alpha, which is tangent squared alpha. From the same formula. Which formula? This one. Oh, I have it here. This one. Tangent A plus A. Tangent A plus tangent A is twice tangent A. 1 minus tangent A times tangent A is 1 minus tangent squared A. Okay, so now let's practice this. We haven't discussed the alpha over 2 yet, so let's work on either sine twice alpha or cosine twice alpha, and then we're going to go to or tangent, and then we'll discuss the tangent over 2 in a minute. The half angle. So which one would you like to work on with double angle? Any. I know everyone is tired towards the end of the semester, so please, let's work on this. It's important. Anyone would like to choose?
We do E.
Perfect. So we want to look at 16, and we want to determine tangent twice theta. And we're given cosecant theta equals negative the square root of 5. And they're telling us that cosine theta is less than 0. Perfect. So remember, cosecant is 1 over sine. 1 over sine theta equals negative the square root of 5. And I swap because it's a proportion. And I write that sine theta equals negative 1 over the square root of 5. So I know that sine is negative in these two quadrants. And I also know that cosine is negative in these two quadrants. Therefore, theta is in which quadrant?
Third.
Of course. Thank you very much. Of course, it's in the third. Good. Now I have to write the formula for tangent twice theta. They're giving us some information that they want us to determine this. Good. But I have to write the identity first. And the identity for tangent 2 theta is 2 tangent theta over 1 minus tangent square theta. In order to determine this, obviously I only need to determine tangent theta. In the third quadrant, tangent is positive. So I have to, because both of them both sine and cosine are negative. So then tangent must be positive. Okay, perfect. I have sine. I can determine cosine. So with sine and cosine, I can determine tangent. So let's find cosine theta, which is negative. It has to be negative. The square root of 1 minus sine squared. I'm going to write it as sine squared first. So you remember the identity, 1 minus. This squared is 1/5. So remember, we are squaring a negative number. The answer has to be positive. The numerator squared is 1. The denominator squared is 5. So 5 minus 1 is 4. Negative 2 divided by the square root of 5. I'm going to leave it alone for a moment. I'm happy. Why am I happy? Because I have sine and I have cosine. So now it's a piece of cake to determine tangent, which has to be positive. They are both negative. Both are negative. So when I divide, let me write it. So for tangent theta, I divide negative 1 over the square root of 5, and I flip the square root of 5 over negative 2. These two go away, so the answer is 1/2. So all I have to do, go back in the formula, replace this by 1/2 and replace this by 1/4. Okay, 2 times 1/2 over 1 minus 1/4. Why 1/4? Because I had to square it. So then the numerator is 1. The denominator is 3/4. So when I flip 1 over 3/4, I get tangent of 2 theta to be 4/3. Tangent 2 theta equals 4/3. So this is how we use the identity. And the rest was learned a long time ago, how to find the sines and the quadrant, and how to determine sine, cosine if I have sine, and how to determine tangent. Okay? Any questions on this? Okay. So I think we should move on to discuss the half angle formula so we can work on the half angle. Is that okay with everyone? Do you want to choose any of the other double angles? Or we can move on to half angles.
Could you do B?
Yes, perfect. Let's do B. What was B all about? Okay, I see it. Cosine twice theta. Perfect. For cosine twice theta, since I already have sine, I will use the formula with 1 minus 2 sine square theta. I don't want to use both. I just want to replace one. Again, when I square this, this becomes 1/5. And I'm done, right? So this is 1 minus 2/5. 5 minus 2, so it's 3/5. And this is it. Could you have used the other two? Yes. But for this one is more work because I have to replace both and square them. Could I have used this one? Yes. I just had to replace cosine, square the cosine, and put it in there. It doesn't matter, the answers have to be the same. I chose the one that I only had to square one quantity, and it was easier for me to calculate. It doesn't matter, though.